Gait cycle, mid-stance. In mid-stance, the hip extends until it's in 0 degrees of hip extension. The ground reaction force vector goes up through the greater trochanter of the femur and posterior to the hip joint. This causes an internal flexion moment and external extension moment at the hip. Due to the extension moment, the pelvis rotates posteriorly. During mid-stance, the hip flexors are eccentrically activated while the hip abductors are isometrically activated. The knee extends to 5 degrees of flexion while in mid-stance. The ground reaction force vector goes up anteriorly to the knee joint, which produces an internal flexion moment and external extension moment at the knee. The knee extensors are concentrically activated during mid-stance. During mid-stance, the ankle dorsiflexes into 5 degrees of dorsiflexion. The ground reaction force vector is anterior to the ankle joint. This causes an internal plantar flexion moment and external dorsiflexion moment at the ankle joint. In mid-stance, the plantar flexors are eccentrically activated.
The mid-stance phase, also known as the single leg stance, starts when the contralateral foot is lifted. This phase focuses on the body transitioning from absorbing shock to acting as a stabilizer, which is supported by a single leg. The normal gait patterns during this phase involves the leading hip and leading knee extending to neutral position. The ankle also transitions from plantar flexion to around 5 degrees of dorsiflexion. This phase ends when center of gravity shifts to be directly over the forefoot of the supported foot. Some examples that could contribute to abnormalities during the mid-stance phase could be pain, leg length discrepancy, meaning one leg is shorter than the other, circumduction of the hip, toe walking, individuals that have Parkinson's disease, and Trendelenburg sign. Individuals with Parkinson's disease tend to have a shuffling gait, which can result in a decrease in time that they're in the mid-stance phase. Circumduction of the hip would increase the time the individual is in mid-stance phase, since the pattern of bringing the back foot around to the front takes longer versus the hip solely transitioning from hip extension to hip flexion. Toe walking would create a significant decrease in stability during this phase, which would decrease the time the individual stays in mid-stance. For individuals that have Trendelenburg, they can't balance because the body does not weight shift to the stance leg. This diminishes the stabilization that's supposed to occur during the mid-stance phase.
Next is the primary muscles involved with gait during mid-stance. One important thing to note is that the phases of gait aren't frozen moments in time, they're continuous. During mid-stance, the momentum of the body moving forward is doing most of the work for the muscles, which leads to the triceps surae and hip flexors contracting eccentrically throughout the phase. The triceps surae being the two heads of the gastrocnemius and soleus for plantar flexion. For isometric contractors, the hip abductors play an important role contracting constantly throughout the motion to prevent hip drop and Trendelenburg gait. The ankle inverters, everters, and general intrinsics of the foot are also slightly contracting to provide stability to the foot as it goes through the ankle rocker phase. For concentric contractors, in the very beginning of mid-stance, the quadriceps contract to lock the knee in extension, then take a back seat as the line of gravity moves anterior to the knee, helping to passively extend the knee without any muscle activation. Additionally, the hip extensors, primarily glute max, contract to push the body forward as the foot is planted on the ground. Once again, most of these muscles are pretty quiet during this phase due to the momentum of the body, but these are the main muscles activated to help get the body through to the next phase.
Mid-stance is the first half of single leg support. Mid-stance starts with the contralateral foot is lifted off the ground and ends when the supporting leg's heel begins to raise. Mid-stance is 12 to 31% of the total gait cycle. Mid-stance uses ankle rocker and passive structures to maximize efficiency. During the mid-stance, the leg is almost fully extended and uses the dorsiflexors to lean forward. This uses small muscles to create momentum and move forward.